Hey guys, so today we are talking about segments for lesson 1.3. For today's lesson, you're going to be able to define congruence. We're going to talk about what that word means. And you're also going to be able to define sketch name and identify segments, and define bisector and midpoint and apply the definitions to solve problems. So today you're going to be doing some algebra, okay? And that's where the application of the definitions come in. You are going to take a second, a minute, however long you need, to complete this section here on your own, the think, pair, share. You're thinking, you're pairing, and you're sharing on the page. Well, actually, you're not pairing, so maybe cross that out unless you have a homework buddy or have somebody who you do homework with. All right, but think and just write it down here. All right, so it says in the space below, draw segment AB where C lies between A and B. So interpret that however you see fit and actually draw that image in this space here. Once you finish doing that, let's talk about equality versus congruence. And so a lot of people get confused about that. When it comes to geometry, you must know symbols, okay? Because symbols mean, everything means something in geometry. And that's maybe why some people find it a little bit more difficult. But let's talk about it. So a segment is an object. So this is what we call an object, but its length is represented by a number. So a segment is a one-dimensional figure or object, and that one dimension is the dimension of length, okay? So the way the length is represented is just by writing the letters AB, which are the endpoints of the segment. The way that you would indicate the object or write what the object is by writing those two endpoints, but using the segment notation right on the top. So segment notation is to indicate that, yeah, this is segment AB, but just representing AB without segment notation means this here is saying the length of AB. We're going to get into what that means very shortly. So let's talk about equality versus congruence. Numbers can be equal. Objects are congruent, okay? What's the difference between the two? So equal means that it's the exact same value. And because length is represented with a value, then lengths can be equal. But the objects themselves, we know that they are congruent if I take this object, lay it over, let's say, the object that or the segment you're going to draw here, and they overlap perfectly, and one is not longer or shorter than the other, they just fit right perfectly over each other. That means that they're congruent, okay? But if they're, and congruence will indicate that they are the same length. So congruence, yeah, and equality, pretty much the same, but just they represent different features, okay? So congruent, in essence, is identical in form. So two objects or more are identical in form, and they coincide exactly when superimposed. Superimposed means put one on top of the other. Put one on top of the other, okay? And coinciding means that they lay flat, no overlapping. One is not shorter, one is not longer. All right, so let's talk about this section here. So it says here, segment AB and CD have the same length. If two segments have the same length, they are congruent. And that's what we just said. So if the lengths are the same, the segments are congruent, because this, right, this segment AB and this segment CD, if I turn it, put it on top of that, lay it flat over, it will superimpose, or rather not overlap. Or by saying overlap, I mean one is not going to stick out. They are going to, you're not even going to notice the difference between the two lines because they're just going to sit right one on top of the other. All right, so here it says segment AB is congruent to segment CD. How would I write that? I would write my AB with segment notation. This is my congruence symbol. So this symbol here means congruence, and segment CD. So the way we would write this situation is exactly like this. So this is an example of a congruence statement. These become important as you start working with proofs. And proofs are not everybody's favorite, but you know, we got to do them. So that's why these symbols and things become extremely important because of writing proofs, okay? So this symbol here means congruent to. Now, if I wanted to write the length of AB equals the length of CD, notice I would write it this way. AB, no symbol, is equal to CD. No notation rather, not symbol. No, segment notation on the top. Just AB is equal to CD. And so AB and CD represent lengths of numbers, or numbers, excuse me. So you use an equal sign. All right. How do we indicate congruence? So if we're saying that these two are congruent, excuse the wobbly pen. If we're saying these two are congruent, the way we indicate that is using tick marks. So these are two congruent segments, and I'm showing that with the tick marks. So when I see that and that signals these are the same exact length, and if I lay this flat on top of that, they would superimpose, okay, and they would coincide. Next page. Okay, so here we start talking about dividing a segment in half and segment bisectors. What does that mean? What is a segment bisector? Well, let's take a look at the diagram. I have these two objects. One is a line, one is a segment, and I see these two tick marks, which lets me know that segment RS is congruent to segment ST. They're the same length, okay? But what happened here? So I noticed that this line intersects segment RT, and it intersects at point S, okay? Line N is a segment bisector. Line N is taking this segment and splitting it into two congruent parts. Any point, line, segment, ray, or plane is a segment bisector if and only if it divides a segment into two congruent segments. I call them parts, but they are segments, right? So line N bisects segment RT, and segment RS is congruent to segment ST. The length of RS is equal to the length of ST, okay? So that is our segment bisector. We're going to see quite a bit of that. All right, so now on to midpoint. Let's take a look at what we have here. All right, so I see segment PQ. I see two sets of tick marks. Sometimes you're going to see 3, sometimes 4. As long as the same number of tick marks are indicated for segment PM as are indicated for segment QM or MQ, that means that segment PM is congruent to segment MQ. I'm going to write that here. So segment PM is congruent to segment MQ, and the length of PM is equal to the length of MQ. What's a midpoint? A midpoint is a point that bisects a segment, okay? So it is a point that sits right smack in the middle, in the center of a segment, or you'll see it'll be in the center of other objects in some cases. And it is that point, much like S, where the two segments are split into two congruent parts, okay? So a point is a midpoint if and only if it bisects a segment or divides a segment into two congruent segments, okay? That's the end of this video. Go ahead and try it out. Remember to watch the supplemental videos. Have a good evening.